All right, so we're going to be going over school interface 1. Our student John Winko has allowed us to kind of look at his code, see what he has done. We'll ask some questions and kind of learn about what we're looking for this challenge. John, did you have anything to say before we start?
Well, I didn't commit the last changes. I had some notes in there, but it shouldn't affect the, I don't think it'll affect the running of it.
Gotcha. All right, we'll get the notes verbally through you if we have any additional questions. But yeah, thank you so much, John, for letting us look at your code. And I know we've talked about, seeing more student codes, so I think this makes sense here. So let's actually make sure we understand what the challenge was. So school interface 1, we're building like kind of an actual application, right? Like we're still using the terminal, and I know that's not like, really hot and like, attractive to kind of use the terminal as a UI. But right now we're still stuck in the terminal. We don't have great UIs. We want to create like a menu interface. So sorry, my rendering here is a little weird, but yeah, we want to create a menu.
Oh, real quick, I have to pause you on that one. I did not create the interface because there was a change to it. Okay. So I didn't get to that part.
Gotcha. Okay, cool. That's fair enough. But the main focal point was creating our classes. This is how we're going to reflect our data in our application. So to start, we know we're going to have some students, some staff members, and a concept of the school that we want to model. So we want to definitely set that up. So we have some some starter code here to what your school, student, and staff partition will look like. It looks like this needs to be edited. So let's do that quickly. I guess this is on John's. Sorry. Let's go back to Quebec Platoon. But yes, overall, we just want to structure this appropriately. So let's take a look at John's classes, and maybe John can kind of talk about it. So one thing I did like that John has done is he's created a folder for his classes. So again, this is not required, but good organization to say, all right, I have some small modules that I'm going to use in my application. Let me just nest that on their classes because those are the items that I have. So it looks like we have 4 files. So I'm seeing 4 different classes here. Let's start with our school class. So that's kind of like our overarching thing here. Anything you want to mention here, John? Just kind of guide us through here. I see you have a to-do statement, so let's just talk about that.
Right. So for mine on the all students and all staff is just returning a list of dictionaries. And I'm just wondering if now or for the future iterations of this, if we're just going to go ahead and instantiate those classes from the data we get from the CSVs, because I haven't done that yet, but possibly I should do that.
Yes, I don't know if you're looking ahead or just kind of assuming what's going to come ahead, but yes, we're going to want to use dictionaries as our source data and use the dictionary to kind of create our instances for us. Now, some of you, I know you guys kind of got ahead to school interface 2, which is great, but you probably saw that in school interface 2, where we should be able to use a dictionary and easily create an instance based on the data we get from our CSV files. So the process is we have data in our CSV files, we read them into our program. An easy way, again, I know we haven't covered this, so that's going to be apologies on our side, but we could read that in as a dictionary, which makes it easier to access the data. And then once we have that data from our CSV file, we can convert that data into our actual objects in our application. So again, our objects are going to be school, staff objects, student objects, and maybe person objects. But that is kind of the flow of this application. Yeah, we will be using dictionaries potentially. Let's kind of table that. All right, so your school class looks sensible to me. So basically the concept of school is, right, you have one school and you have multiple students in them and multiple staff. So the way John has structured this is what we would expect. The school has a name, right? So John, do you mind shouting out your maybe your high school name or middle school name?
Yeah, Ridgemont High.
Ridgemont High. You don't want us to crack your security codes, right? All right, so Ridgemont High might be the name of this particular school instance that we create. So right here, I guess John is actually doing that. So we create a school instance, initialize it with a name, Ridgemont High. So we pass in Ridgemont High right here. Again, I want to reiterate this. I know I've probably said this, but I want to make sure everyone's clear on this. This parameter is not something that we manually had to pass in. This is something that Python is going to do for us just through the class framework. So we do not specify who the self is. Python will automatically deduce what the self reference should be. So again, this is just a reference to the instance itself. Well, we pass in the name because that's an additional parameter we want to store. So we pass that value in, Ridgemont High, and then we attach it to the instance. So again, self is referring to the instance that's getting created here. We attach a name attribute. So this is an instance attribute to the instance with Ridgemont High as a value. Okay, and then it seems like we have students and staff. So again, these are going to be multiple objects. So students plural, staff is plural of staff, I guess. But yeah, it looks like we're calling into two other classes here. So we have, I assume this is a students class, which we're importing. So I know we did want to cover importing, so we'll make sure we spend some time on that. But basically saying from the student module, import the student class. So without even looking at John's student.py class, py file, I'm assuming there's a students class in there because that's what we're importing. So if we go here, take a look at your students file, John. So we have a file name, which is going to be a class level attribute. We'll maybe talk about that in a second, but then we got some interesting structure here. John, could you maybe talk about what Quargs is doing for you here and what's going on here?
So the Quargs, the keyword arguments, it's passing in a dictionary of arguments rather than individual. It's also students is inherited from person. So it is initializing person with those args as well, basically passing up those variables. And then setting the school ID, which is specific to students from the argument school ID from the KWARs. Is it KWARs, Quargs? How is that spoken in industry?
I pronounce it Quargs just because it flows a little better. But I am not the authority on that, but I think Quargs is probably the more common pronunciation. Definitely a weird sounding name. But yeah, Quargs, again, this is something we covered, I think, in week 1. Just understand that this is a different way to pass in data. So I just want to highlight here. I'm going to make some sample additions here. So if we want to do, student 1 equals a student object, we create it, we would pass in a dictionary here. So let's say we pass in, I guess I'm not going to do this fully, but we could pass in, sorry, I'm just going to change this right now to name. Let's say a student has a name. We could pass in the name right here. So let's say, Bill Gates was a student. He would get a name, and that automatically gets mapped to this parameter. This is positional argument. So we had multiple positional arguments like name and age. Let's say Bill Gates, I don't know how old he is. Maybe he's 72, maybe not. He's probably younger. So we pass in arguments in this format. These are positional arguments, meaning the first argument here gets mapped to the first argument here. Self does not get counted here. Age, this is the second value we're passing. That's going to get captured by age. These are positional arguments. So that's one way to do it. Positional arguments, and this is the normal way we do it. Like in most languages, positional arguments are like the only way to pass them in. So arguments, no extra E. All right, but we also do it with Quargs. So just to review, in case anyone forgot, we could pass in Quargs. Quargs, you specifically target the parameter that you want to assign. So I could do something like name equals, Bill Gates. Let's do a different person. Let's do Elon Musk. And then I don't know how old Elon is. Maybe he is, I don't know, is he 51? I don't know if I'm even close. We can do age equals 51. So now we're specifically telling whoever's accepting these values where to map them. In this case, the order is the same, right? I have name first and age second. That's fine. I'm just telling it specifically which variable here should get the value. But with keyword arguments, I can swap these. So this makes no difference if I put name first or name second. The position, the ordering does not matter. This is exactly going to do the same thing. Because I'm telling it age is going to be 51. So it's going to say, all right, on this side, it's going to be like, all right, what value should age take on? It's going to be the keyword argument because we specify the keyword here and then the value for it. So these are keyword arguments. And that is what John has set up here with Quargs. This is just, this is going to be a dictionary that we break up. So again, this is stuff that I don't think we've fully covered. But Quargs, if I put these back, these are just going to be kind of a collection of keyword arguments. So effectively what's going on is we have a dictionary. So let's say data equals, I'm just going to keep this simple. We have a name is going to be Tom Hanks. And then age, again, I don't know what celebrity age is. Any guess? I don't know, is he 60? Is he 60? I don't know. Probably older. But we have a dictionary. That's what we're going to pass in here. That's what Quargs is going to be. It's going to be a dictionary, right? This operator right here breaks this dictionary into keyword arguments. So once we do something like data, once we do the double asterisk, this is specific to Python. This effectively, this is not valid syntax, so I'm just going to make that clear. This effectively makes it so that we have like floating keyword pairs. We're going to have name equals Tom Hanks. And we're going to have age equals 60. If that's on a string. So this is what this operator does. It takes a dictionary and it kind of breaks them out into like individual units. In JavaScript, it's known as the spread operator. I want to say it's also the spread operator here in Python, but I don't know that for sure, so don't quote me. But here, again, we take a dictionary, spread it apart. So then on this side, we could use the dictionary if we want to, or we can break it apart. So again, here, to be clear what's going on here, we're taking a dictionary, which is the quargs. Quargs is just a name. Again, it does not have to be named quargs. We can name this, something, anything we want. This is just an argument. Quargs is just what we use because that's what they specify. But this is a dictionary. We're breaking it apart so that on the person side, so we're calling person init. On the person side, I guess we get quargs back here. But this lets us, again, get those keywords arguments if we want them. I'm actually kind of surprised here, but maybe that's just some idea. Look at it a little longer. I see 2 hands raised, so I definitely want to hear your questions. Andrew, what question do you guys have? What do you have about?
Not really a question, but just about the quargs. Is this like one of those sort of good best practice things for like larger programs?
I'm gonna say maybe, but it is very beneficial for this challenge because when you read in CSV data, you're gonna capture it as a dictionary, and it's gonna make your life easier when you use quargs. We'll see this probably with School Interface 2, so I know a lot of you guys have not gotten there. But basically, once you get a dictionary back, so imagine data is what you read in from your CSV file. So you're gonna have data for each record in your CSV file. So if you want to just kind of imagine it, each of these records are gonna be converted to a dictionary. So Lisa is gonna have, we're gonna have a dictionary with name equals Lisa, age equals 25, role equals student. And then Jesse's also gonna have a separate dictionary, name equals Jesse, age equals 25. That's where your dictionary is gonna specify, just like I've done with Bill Gates here with my data. But then you can take that dictionary and just basically pass it straight into your class objects, and that you create your objects right there. You don't have to do any like conversion of the data. You don't have to say, all right, well, now I want to, from this side, I don't need to do S3 equals student and then pick apart that data by doing, data name. This is just a little bit more work when I don't know how to do it on this side. Does that kind of make sense? So here, if we had like 20 parameters here, I had to go through my dictionary and say, all right, well, I want data age here. And then let's say there's 20 more parameters. Well, it just gets tedious to type it out. So just passing in a dictionary, just like this here, you would pass in S4 equals students and just pass in data. That's all you got to do. Your dictionary has every field you want. You accept it on this side and kind of just, it makes the flow easier. You don't have to use quargs by any means, but it's going to make this a little easier to adapt to. I see a bunch of hands, so absolutely. Marcos.
Yeah, so when you're using quargs, so where he has it on line 9 right there. So like when I built mine, I just had quargs like as the value that I was assigning self.school ID. Is it necessary to put in the key? Like, does that question make sense? I guess like I just had quargs without the school ID when I assigned the school ID, and my program still ran like for all of the attribute assignments. I just put quargs and it still managed to work out. I don't know if maybe I just got lucky.
Yeah, I'm going to say I'm a bit surprised that works again, because this is going to be a dictionary that you're assigning to school ID. So maybe you were just either accessing the school ID through that dictionary that you saved here, or again, I don't want to speculate, but I guess I am a little surprised that worked, but glad you got it to work.
Well, I thought I read somewhere, I don't know, and like I just read about it yesterday. I wasn't even super familiar with how quargs worked until yesterday, but I thought I read somewhere that using the star operator, like somehow it like recognizes the keys or whatever. I don't know. Maybe I'm completely just making this up, but I thought I read somewhere that it kind of smartly does it.
This operator?
What's that?
The star?
Yeah, like it recognizes that you want to assign the value from the key in the dictionary school ID to the school ID
Gotcha. So
variable.
did you say you had something like this? Or without the star there?
Without the star.
Okay, yeah, I guess I'm a little surprised that works, so I might want to look into that more. I am
Okay.
curious, but yeah, if it worked, then I'm gonna be like, cool. Kat, you have a question? Oh, I think you're muted somehow. You're not muted on Zoom, but yeah, we'll get back to Kat. So Brendan, do you have a question?
Yes, the question I have is on the dictionary portion. So where are we building that blank dictionary so that the Quargs knows where to fill it? Like, where are we pulling that framework from, or does that what it's doing automatically?
The dictionary. So I think this is a challenge for school interface 2. So that's probably what you're going to encounter later today for your challenge. But effectively is we have data that we want. We're not going to create data in our application ourselves. We're going to rely on the data files. So in this case, we have students.csv and staff.csv to create our staff and students for our school. So our goal here is, one, we need to read in this data into our application. So we open up the CSV file, read it in through some mechanism, and we'll talk about that mechanism if we have time. That one way to read that in is via putting that data into a dictionary automatically. So just to kind of give you a hint in case you've not started it, let's go to all students. So here, all right, this is well done, John. I'm glad you kind of centralized this logic. So just to kind of go off here and maybe answer Brendan's question along the way, I'm going to get rid of my code. I don't want to have that focal point. But what John did here is excellent. This is not something I would necessarily assume all of you guys will catch on to, but John got this correct. So here we have a class method. Remember that decorator we introduced on Wednesday? This is something that he is using to load in all students. So this function is called to read the CSV file and get the data out of it. What he's done that's kind of clever here is he's actually calling into the base class here. So he's calling CLS get CSV rows. Notice that the students class has no method called get CSV rows. So the question is, well, what is he actually calling here, right? Is he just pulling something out of thin air? The answer is no. We're actually using inheritance here. So notice that students inherit from the concept of person. So yes, a student is a type of person. It's a more specialized person, but person has a lot of functionality in it. So we actually look into the person class. Notice he has a static method that is going to accept a path and simply read that data file. And he's using Dict Reader. So this is, again, something that maybe you guys not have seen. I'm going to pause here because I may be going a little too quickly, but there's a
Anchor, sorry to interrupt.
No,
so I understand that the CSV file is putting the stuff into a dictionary format.
Okay.
I guess maybe if you didn't have a CSV file, you need some other file that this Dict Reader is able to put the data into a readable way to then output it in those key value pairs?
Yes. So you need a dictionary if you want to use the star operator and have them convert to quarks. So again, that's a lot of terminology there. But yeah, so Dict Reader, I just want to point out here. So the CSV module has something called Dictionary Reader. You guys can read some documentation on it, but the goal of Dict Reader is to take a CSV file, such as students.csv. It's going to treat the first row as headers. So these are going to become your keys: name, age, role, school ID, and password will become your keys in your dictionary. And then your values for each row will be the actual values for the students. This is something, again, baked into Dictionary Reader. This is something cool about Python. They have a lot of built-in functionality because they know that's what developers are doing. So if I go back to person, basically we are using Dictionary Reader, and then each row is going to be a dictionary. So what effectively John is returning here, he's returning a list of dictionaries. So each entry is going to be a dictionary, and each dictionary is going to represent one student if we're reading into it. So one dictionary is going to have name equals Lisa, age equals 25, role equals student. The second dictionary in that list is going to be Jesse, 25, students, etc. So I want to make sure I answer Brendan's question. So we do get a dictionary here, a dictionary here. So this is a list of dictionaries. So we return it from this method. So we trace it back. Let's go back to student.py. looks like we're returning the return value of that function. So get CSV rows returns a list of dictionaries. We are simply returning that back from all students. So if we trace that back to school.py, notice we're assigning the return value from all students into self.students. So self.students is basically going to be a dictionary, a list of dictionaries. However, I have some feedback for John here, and John, maybe you were thinking about this and might implement that, but just to kind of get this discussion going a little further, you're reading in data as dictionaries. This is okay, and it might work for our application, but right now you're representing your students as just dictionaries. And as we talked about, that can work, but we want to use more object-oriented approaches here. So I'm actually going to change this, if you guys can kind of bear with me. We want to actually use classes here, not dictionaries. Dictionaries can work, but classes are a better solution. So when we get a dictionary, this is one thing that I would change in John's code. We should create an object and store a list of objects, not a list of dictionaries. So here I'm going to do something a little tricky, and it's probably going to cause confusion, but it's kind of important to go over here. So I'm actually going to change this to a class method, and you're going to see why. This gives me access to this magic class parameter. And this is something Python will automatically pass to us. So class is now going to be a reference to whichever class is calling this method. All right, so I'm going to try to go a little slowly because I know these are new concepts. But now that this is a class method, CLS is going to point to whichever class is actually calling this method. Again, this is just a naming convention. I can name this whatever I want. I could say my class. I'm just going to actually use a different naming convention here just to highlight you don't need to name it CLS. So this is just a variable Python will pass in that points to my class. Here is the magic part here. We want to take a dictionary and convert it to an object in our program. So the magic, sort of magic, it's not real magic. I don't know if magic really exists, but in this case, we take our dictionary, each row. So if I do for row dictionary, row dictionary in reader, so we're going to do a for loop, basically go through each row in our data file. And keep in mind, this dictionary reader automatically will ignore the first line. This is something built in the dictionary reader. It's going to know that the first line are your keys. Rest of the values are going to be, rest of the rows are going to be your values. So if we do this correctly, and we should definitely double check, we should be able to create student objects. I'm going to say new person, new object, I'm going to call it, for lack of a better name, is going to be CLS row dictionary. And then here, instead of returning that, I'm going to simply return, let's say, all people will be my list. So I'm going to return a list of objects, and this is going to be new person, let's call it. And then I'm going to append into my all people. So this is aggregating all the people I create. So let's do all people that append that new person that we just created. So again, now we're dealing with objects and not dictionaries. And this is what we expect. Again, your assessment is going to have something similar to this. So make sure you kind of understand here. But we're taking just raw data that's just key value pairs or whatever format, but we're actually creating an object. So we're actually using our class. So I'm going to talk about what class is going to be, because this should be my class since I renamed the variable here. Let me actually use camel case here. If that makes any better, we'll say my class. But this is just a variable. Make that clear. So we create a new object, append it, and then here we'd return that all people list. Now, again, I went through a lot of new concepts here potentially, so I'm going to explain it and then pause for questions. So again, the change here is we read in data, we actually convert it to objects. This is what's being done right here. We take data, we're using that star operator. So again, this creates key value pairs. So this is going to basically pass in name equals Lisa, I think was one of the entries. Age equal, I think she was 25. I don't remember the rest of the details. That's what this is doing. So if we go to student, let's kind of backtrack and make sure we understand what's going on here. Now I've converted this to a class method, not a static method. That means my student class is what's going to be referred to by that CLS variable, or in this case, I renamed it to my class. Again, I would not normally do this. I just want to highlight that this is just a naming convention. You can name it whatever you want, but this is actually going to point to the student class. So what I'm doing right here, I'm actually, you can imagine, I'm calling the student class right here and creating a student object right here. But we are actually in our person class, not in our student class. So I don't want to hard code student here because this is reused by the staff class, which we have not looked into. But if we look into staff here, notice that staff has something very similar. We are opening a file path and then passing that path down to get CSV rows. So now CLS in this case is going to refer to staff versus in this case, CLS refers to student. But they're both calling down into the person class because they both inherit from person. So if I go to staff, notice that staff also inherits from person. So person has this method. So if I go back to the person class, and hopefully I'm not bouncing around too much, this method is used both by the staff class and the student class. Now the question is, well, how can both use them, get what they want out of it? So the answer is this special variable, which we normally name CLS. So I'm going to change it back to CLS. So this says, hey, if you're the student class calling this method, I'm going to create a bunch of student objects for you right here. If you're the staff class calling this method, well, cool. CLS is going to point to staff. So you're actually going to create new staff members right here. So this is generic, and this is always going to point to the correct class wherever it calls down into it. So students will be created for the student class. Staff will be created for the staff class. Regardless, we just collect those objects. So we have all people. All these people might be students. All these people might be staff. We don't really care at this point. We just return it. And then that return will be captured by, the all staff method. And that is called by the school method. So now self.staff, this is going to be a list of staff instances / objects. Those words are kind of interchangeable. So we have a bunch of instances we created. So now we're actually using our class appropriately rather than having a list of dictionaries. That can work, but that's not the OOP design. We want to create objects or instances of the student class and of the staff class. Okay, I said a lot there. I see hands raised. I'm sure there's confusion there. So Lyman, I see you've had your hand up for a while. So sorry if I kept you waiting.
Yeah, so I guess what's really going on, it's like simulating importing external data. And could one way to refactor it, I know we're doing it inside of the person, could you even just take that logic outside of the classes altogether, not rely on inheritance, which is where you can have you can separate that logic almost like, because that logic's dealing mostly with the ingestion and conversion of data. Could that even, I would almost take that out of these instances of classes?
You could. So again, a lot of this thing, and I have mentioned this, some of the frustration with OOP is it's very just nuanced and design related. Yes, I could create a method here that says, that's a standalone method that says type of class and the file path. Yeah, there's no inherent reason why we need to have this method inside of the person class. But the design reason is because this only applies to people. It's not going to apply to dogs or whatever. We're deciding that. Sorry, it's arbitrary. But here, this is doing some work for us for person objects. In this case, we have students and staff. And since that's related to what we want to do, it just makes organizational sense to just kind of nest it as a class method. But you're right. We could have a standalone get CSV method. If I want to change it right now, I'd say, instead of calling it on the class object, I'd say, hey, I'm a student class. I'm passing you the path. Create some student objects for me. It's gonna, this will be student and this will be path. It's effectively the same thing, but in this case.
So I guess it's like a design thing. So it's because this functionality is designed just for other classes related to person. So it could make sense to put it in the person class that all the other classes that inherit from it can access.
Yes. One more feedback for John. Again, John, I know we were kind of picking at your code. Usually I'd recommend this should be a singular name because you're creating student, a single student. So I actually didn't realize that until now, but this should be named singular not plural, because it's not keeping track of all students. You're creating student instances. So it's a student concept. It's not a concept of students. I know that's kind of maybe nuance there also, but again, most of the time your class name should be singular, because that's the appropriate thing you're trying to represent. You're creating individual students, one student at a time with this class. John, you have a question?
Yeah, I was gonna say that was one of the things I was gonna have changed is the plurality. Also, as a recommendation, if you might want to close the Explorer and split the person class, it might be a little bit easier to talk about things, how they're related without jumping back and forth.
Sorry, yeah, I appreciate the feedback. Yeah, I kind of sense I was jumping back and forth a lot. But yeah, split view definitely should take advantage of that since VS Code lets us. Makes it a little harder to read the wraparound code, but all right, yeah, so we have side by side. Again, this is our student class. I renamed it, but it was students. This is a class method. So again, class method means we don't need one instance, any instance to exist for this to happen. And we're actually seeing that in our school. Notice we're calling a class method through the class. No instance got created here. So we do this, and yep, it makes sense to nest this inside of a class, because this is, creating student instances and doing some student related work. Now, this doesn't have to be in our students class. It's design organization, but I agree with John that, hey, this is loading and creating student instances at the end of the day. So it makes sense to be a class method here. Jesse, question.
Yeah, this is probably a simple question for most, but I understand the import CSV file. What does the import OS do?
Yeah, so I think a couple students have this question, so I don't think it's, it's definitely good to ask it. I think this is used for file path. So here you need to provide it like the full path. So I think you have your file name and then your path. Where does my path come from, John?
That's inherited from person.
Oh, okay, gotcha. Oh, there it is. Yeah, so we're using, this is just a module to kind of help you resolve file paths, simplify it. So notice OS path, absolute path. This is a variable that points to whatever file kind of launch your application. So this is saying, this is relative to this file, but this is saying find the directory it's in. It's just creating a full path for you. It's kind of the summary of it. So yeah, the OS module kind of makes that possible. It's just built into Python. So you definitely might see it. I know we didn't cover it too much, but you could read about it. And mostly the goal here is to get a correct path here so we can actually open up our file. I don't know if that was satisfactory, but yeah, it's just helping us do something for opening and reading files. But yeah, it is being used right here. I did not touch that. More hands. Just yeah, so you have still your hand up, or did I answer it? Yeah, I know. Sukdev.
Hi, Ankur. You went through that object versus dictionary design decision. Can you repeat that again,
Yes.
please? It was very fast for me.
Yeah, glad you asked it, because this is a very important concept, and this is your assessment too is going to rely on you doing things correctly. So absolutely want to spend more time on it. Apologies for that beeping. But here, the change we made in our person class when we actually read in the data file. So this is our reading in our CSV file. I added this in for John's code. Previously, he was reading in the data as dictionaries and just storing them inside his application as dictionaries. So basically what students right here on the school level was basically, if I can kind of just draw this out here, was going to be a list that probably had multiple entries in it. One entry was going to be name, and I think we had Lisa. I'm not going to create this full dictionary. Age was 25 and so forth. All right, so this is what his data looked inside of his application. We had name Lisa, we had Jesse as another person, and so forth. I'm going to add one more. There, rule of 3. Name, I think Slater is another character. So this was what his students, this is what his self.students was referring to in his school class. It was basically a list of dictionaries. Why am I getting these squigglies here? Oh, I'm not sure why this is yelling at me, unless you guys spot something, but this is what his data looked like. I changed it so that now his students, let's say other, I could reassign it. I suggested and will say that the better way to do this is now you have student objects. You have something called Lisa and Jesse and Slater. And these were pre-created ahead of time. So Lisa refers to a student object that has a name of Lisa maybe, and an age of 25. So we created these objects. These objects were created on this line right here. The way they were created is we took the data from our dictionaries, basically fed this dictionary into here effectively. Not quite going on because we are actually using the spread operator. So that made it, we were passing in quargs. So this would, let me try to kind of simulate this. We're doing double ampersand with a dictionary. This dictionary came from our CSV file. So effectively this becomes keyword arguments. We're doing Lisa equals student, name equals Lisa. So again, back to those keyword arguments that we talked about. And now we just used our data we read in from our CSV file and created a student object. So now my students are referring to objects. And why is this beneficial? Well, let me change something up for you. Like what if I added a method here saying, you know, def, let's just do def str. Yeah, let's set a str method. I'm not sure if that's the best thing I want to do, but let's return, you know, awesome student named self.student. So now we have access to this method should we want to use it. Our dictionary does not have a method that, you know, we could create a method. I don't want to spend too much time on that, I guess, but it's just better to have classes. Now we have methods and data and we use inheritance now, right? So that's another benefit here. Because now we are properly kind of using name and age. Those are related to people. So now our staff also can benefit from that inheritance because we're using people behind the scenes. So person class is keeping track of all that shared data. We cannot achieve that with just using dictionaries. And so that's going to lead to more repeated code. This is just not the best way to structure your data. Again, it can work. Dictionaries and classes have a lot of, you know, same benefits, but classes offer you more design-oriented thing. Again, inheritance, that's one benefit. You know, creating class methods, instance methods, having that relationship between them. Just a lot more you can do with classes is the high and low of it.
And just to follow up on that, so the Dict Reader will assign that first row to be the key. So when you're doing the quargs for row dictionary, it's just going to assign the values. But how does it know that the value for name is going to be the object for the students list?
Sorry, was the question, how does Dictionary Reader know that Lisa is going to be the name?
Yeah.
Yeah, great question. So we look at our data file, and this is a lot of magic built into the Dictionary Reader. What Dictionary Reader does behind the scenes, I'm just kind of extrapolating here. Dictionary Reader is going to say, all right, cool, you pass me a file with some data in it. I'm going to read your first line, and I'm automatically going to assume that these are your keys for each of your records. It's going to say name, you're going to have a name, age, role, school ID, and password. So it kind of slurps up the first line and says, all right, these are our headers or our keys for our dictionary. Then it's going to read line by line. That's what this for loop is doing right here. Next, it's going to say, all right, you want a for loop. Each row is going to be a dictionary. This is, again, something handled by Dictionary Reader. I have not done anything magical here. Basically, the reader is going to give me a bunch of dictionaries back. So I get this dictionary back, which was, sorry, I'm still flipping back and forth. So that's going to be this dictionary right here with name, age, student ID, whatever else was in that data file. That's a dictionary I get back. That's what row dictionary is going to look like. And then I'm going to create a student object from it. So that's what I've effectively done right here, where I create a student object from that dictionary. So that, just to double back on that question and answer, Dict Reader automatically knows, hey, the first value in this list is going to be assigned to name. The ordering here matters. So name is listed first here. So whatever value reads from this line, like whatever line reading logic it does, it's going to say, all right, Lisa is going to be, the value of Lisa is going to be mapped to the key of name. And it's going to do that same thing for Jesse, because that's where Jesse is listed. It's the first value. Dictionary Reader is like, all right, every first value is the name, every second value is the age, and so forth. So yeah, there's a lot of magic behind the scenes. You can read more about Dictionary Reader, obviously doing some Googling, but that's, again, the summary of what Dictionary Reader is accomplishing for us. Sukhdev, did that clarify? I know that might still leave some questions, but want to make sure we addressed it partially.
I think, yeah, that was very good. Thank you. And I think as you were going to student, it looks like we're assigning the object name, the student object. So that's why in that list of objects back at that student.py, you had named it, or was it school maybe? Yeah, you had named it Lisa Jesse Slater because we're assigning that student object name.
Essentially, yes.
Right.
So what I have
Okay.
here, it's what's being done on line 26 here. A new person here. At one point, it's going to be Lisa because we create data for Lisa. Next time, it's, sorry, that's Lisa. That was close. Next time, it's going to be Jesse. So these are just variables, but I'm just making it generic because we're in a generic class here. So I'm just going to call it new person. But we're creating instances for Lisa, for Jesse, for Slater. Each time we create a new student. So what I've highlighted here, class.row dictionary, is the same thing I have right here. Sorry. These two things are the same thing. I've hard coded it here. Here it's whatever the CSV file gave to me.
Okay, thank you very much.
Thank you for your question. Brendan.
Yes, Anchor. So on the person class, the MyPath OS terminology, if John didn't use that, then on line, where is it? 19, where that's, I believe, where he's calling the pathway he created up there, would we have to type in the location of the CSV file on our computer? So we'd have to say,
Yep.
from wherever we start all the way down. So
Yeah.
without that pathway, that pathway is just setting exactly what's it doing there.
This is getting our base path. So this is the base path to kind of where these files exist. And then if we go to student.py, we're using that base path right here. So this is the base path, and he's combining with the file name. In this case, for students, our file name is data students.csv, but for staff, sorry, I know I'm bouncing around. Staff, it's a different file. So basically the same generic path because they're in the same location, but then each class has its own kind of data file that we want to read from.
Because they're all under the, in this case, what are the school creator, student creator file, right? Since they're all located in the same, I don't want to use the wrong terminology, but repository, we're just kind of pointing back to a higher step on that, and it allows it to go
So,
back down.
My path is going to point to your folder here. So if I go back to my terminal here, if I do PWD, my path is going to be this whole thing. It's going to be user/Quebec/code/Quebec/lectures. That's what my path, literally my path here is going to be that. And then he's kind of appending the data/staff CSV because that's where the actual files are. So I have the base path to school John Winko, and then the file name is combined here. So os.path.join just gives us that full path. So now I have this whole thing /data/students.csv so that I can actually open that file. You can probably get this to work without the OS join. I don't want to spend too much time on it, but just know that that's just giving you a full path to open.
No, thanks. That answers it.
All right, cool. Kat, I know we left you with some audio issues. I apologize for forgetting about that. Do you have any questions from something in the past or right now?
Yeah, just a quick question. For the refactoring that you did on the person class and student, did you change anything in school to do that as well? Or
Nope.
school? Okay.
School did not change. I added some comments to kind of highlight what we changed. So initially, the way John had it, which worked, so I'm not saying it was bad. We were getting a list of dictionaries. So that's how our data was represented. But we actually want to create actual instances from our classes. This is what OOP design is meant for. And this is what you should be doing with your codes. Again, we have this class, we should use it rather than just using dictionaries. Yep. So school did not get modified. The only thing that got modified was the person class. I, in fact, did not change anything on student either. This I did not touch. That should be class though. Sorry, a couple more questions and then we do need to wrap up here. Jake.
Yeah, I was wondering, like up until now, we had typically been creating an instance and like setting it equal to a variable, like Lisa equals student and feeding in. I wasn't quite sure how to handle when all of a sudden we're creating a dictionary and then you just create the student instance by saying student and then passing all that in, and you're not setting it equal to a variable. So then I wouldn't know how to access Lisa at that point. And unless of course you put her into a dictionary or something, and then you remember the dictionary name and you cycle through and look for Lisa, name Lisa.
Mhm.
But are there any like built-in methods that allow you to like list all the objects that were created using a particular class? Like in this case, every student that was created using our students class here.
Yep.
Where you could do like a little trick that would print out this, here's all the students that were created using this
Yes.
thing.
So there's no default built-in way for Python to manage, like, if we create 50 students, our student class by default is not going to have some way to know, all right, you created 50 students, here they are. But we are keeping track of students. So keep in mind, we load all the students in, we create this list of student objects. So we have all people, we create individual students here or staff, whatever we're creating, push them into our dictionary, into our list, and return that list. So get CSV rows is called by student.py, which is called right here. So the all students method will get a list of student objects, and then we're storing that in our school. So our school is our manager here in terms of we have self.students keeping track of every single student that was created here. So if we did want to go through that, we could do something simple. So I'm going to get rid of some of this code. Let's look at John has school written down high. If I did something like for student in school.students, because students is an instance attribute for our school, we have ability to now see every single student that was created here. So I print out S. I'm not sure if this code's going to run because I made a lot of modifications, but yes, school.students is keeping track of every single student that was created. That is what we chose to do. Now, we don't have to keep track of every student, but in this case, we do want to because we're going to do some additional things with them. Is that kind of clear there, Jake?
Yeah, I knew if we keep track of them and we continue to add them to a list or something that you can access them through the list.
Yeah.
But I just didn't know if there was a way, like some sort of dunder method or something that keeps track of that for you automatically. Like
unfortunately,
would be useful.
Python's not going to manage the data for you. You got to manage the instances you create if you want them. All right, a few more questions, but I might need to cut this off soon. So Andrew, question?
Yeah, my question was actually similar to Jake's. So the line 26 on person.py, how it assigns it to new person.
Yeah.
What if I don't want it to assign it to new person? I want to assign it to like Lisa or the names. Like, is there a way to do that variable, like where it keeps changing like the left side of the assignment as it goes through?
So again, these are just variable names. I don't need to create a variable here. I could technically do this all in one line. So variables can be named anything you want. Like obviously we want to name them sensibly. So that's why I created a variable named Lisa, because I'm creating a student object for Lisa. But these are just names pointing to data. So whatever you name your variables, at the end of the day, doesn't matter for the data itself. So here, I just do this all in one line and say, create some student object and push it into my list. So now we don't need variables because our list is kind of keeping track of all the data like in each index. So like, yeah, I don't necessarily know off the bat that the first student is Lisa, but I would investigate the name and say, all right, first student is Lisa in my records. So again, don't get too bogged down on the variable name. These are just placeholders kind of pointing to data. But yeah, I guess I don't know if that's.
My question was more of, it wasn't like the variable name thing. It was like, is there a way to make it so that it's automatically assigning the actual name there where like that, it keeps changing for each person. Like Lisa will be the first one, then it switches to someone else.
Okay.
Then it switches to someone else.
I don't think that's possible, but I guess my counter question to you, Andrew, is why do we need that? Because just to clarify that, we could create, let's say we had some mechanism where we created Lisa here and then it automatically changed to Jesse for the next value. Let's say that was happening. All we're doing with this variable right now is passing it and passing the data into our list here. So let's say we append Lisa and then pass Jesse here. Well, that's not going to be reflected in our list. Our list is simply going to be looking like, it's going to be, students, and it's just a list of data. It's not going to have, it's not actually going to have Lisa and Jesse in them, because those were just variables pointing to data. So this was maybe a bad example, kind of misleading here. This is not going to contain something called Lisa. It just has some student object with name was equal to Lisa and so forth. And then it has another student object that we created. So these are just data points. They have no inherent, identification other than the data within them. So name equals Jesse. So again, even if we, create a variable name dynamically here and push it in here, that is not what our data actually looks like. Our data looks like this, where we have actual student objects that were created and pushed into here. I feel like that there's still some confusion there. So we might need to double back on this, but again, the variable name here does not matter for a single thing. It's never used again. We are simply using it as a placeholder. As I said, I could even do something like this and nothing has changed with the data. I'm doing it all in one line. So now I'm create a student object. I created this object and pushed it into my list right here.
Yeah, I see what you mean, where it points to something. I just thought in my head it'd be like an easier way to organize it.
Yeah, so again, apologies if I confuse anyone here. We are not actually storing like named variables in our list. Our list stores actual objects, so student objects, not named, no name variables there. All right, a couple more questions here, Sean.
Yeah, so I just wanted to clarify something because I do really like how John refactored this. Can we go to a student.py? Where is it at?
Sure.
Okay, yeah, so that class, at that class method, so it has return cls.get that CSV rows. So with that CLS, it's gonna first check students if it has that method, right?
Yep.
But since it doesn't, it's gonna go up to person. That's
Bingo.
how it's working.
Yep, absolutely. Great phrasing. I'm glad you clarified that. But yes,
Okay.
that's
So-
how Python works. Go for it.
Okay, so if you put super there, does that work the same way?
Yes, super would work here.
I guess what's the difference? Like, I mean, so it worked the same way, right? Like
almost the same way. The
Okay.
difference here, let me just, it's a good thing. It's not always clear. There's these mean two different things. This, as you said, sorry, it's gonna be grayed out. Let me just not return them right now. These are gonna do similar things. In this particular instance, the same exact thing is gonna happen. But what you said was correct. This will search students.
Oh, I get it now.
first,
Like if
and
it's gonna
then person,
sorry.
if not found in student. This is what if you call it through the class. But I think you realize.
and then super is just gonna go directly to the first one.
Got it. This
I
will
got you.
always go to the parent class.
Well, wouldn't super make sense here more?
Not necessarily. So what if we want to do some additional logic? So we could create another method here and kind of override this and do something extra and then call down to the base class. So this is again more with inheritance that I think we just covered yesterday, but this gives us the option to override guest CSV method on the student level and do something extra if we want to. This says always do whatever the base class is doing or the parent class. Don't allow us to do anything extra. So I'd say this is preferred in case you need to change it in the future. Like, oh, we realize we need to actually do one more thing when we're loading in students. This will give us the option to seamlessly add that in here. If we use super here, then we would need to actually say, well, no, we need to call CLS or student here specifically. So this, the way John did it, is slightly preferred.
All right, cool. Thank you.
Thank you for that great question. All right, Aiden, you're going to get the last question here because we need to get you guys through your assessment here. But great questions. I think this has been a good review for this challenge and answer some questions. But Aiden, go for it.
Could you, so it's actually in this file. So in student.py, you have your original init method, and then you create that reference to the super person in this case, and you init to get the values of an person of the parent class. Why do you put self in the arguments there? Because yesterday Kat and I were putting self there, and then we were getting an error that we were trying to use too many arguments when calling it.
Sorry, there's a vacuum going on in my hallway here, but hopefully you guys don't get distracted by that. Great question. This is kind of just a Python thing. This is correct because John is specifically calling the person class. I would modify this, that this should actually be super. And when you use the super method, you do not need to pass in self. So this would just be quargs. Again, apologies for the noise here. But again, super is preferred here because hypothetically, let's say instead of making person base class, I want to make this like dude. Dude is my base class now. Well, if I make this change, the way John had it, I would need to change this here. And that's just one extra place where I need to change it versus super will automatically know, all right, you want me to check dude because there's, that's what you change it to. The super is kind of flexible. Hard coding person here is a little less flexible and a little less preferred. But if there's some reason you want to specifically call the person class directly, this is the way you do it. And if you opt to do it through the class name, you need to pass in self. If you use super, you do not need to pass in self. So that's a small distinction there. Both of these would work exactly the same way in this case. This is the slightly preferred Python way to do it because super is flexible in that if you change your base class, super is going to know about it versus this line will not know automatically that your base class changed.
Ankur, I want to step in real quick because I have a note from if you look on school.py where I had the exact same issue where it complains about the number of arguments. It was simply because I did not expand out the kwargs when I passed them in. So if I didn't put the star in the constructor, or if I didn't call the function with the star, I'd get that error.
Okay, so sorry, was that a question or comment?
Kind of a comment for Aiden on how to fix the issue.
Gotcha. All right, great questions here. Again, I feel bad about cutting this review short because I think this has had some great questions. Kind of got to see some great code here. So John, thank you so much for again volunteering your code as tribute. I think you had a great solution here. Again, a few modifications I would make. Again, just to kind of double back, this is essential for all of you guys to understand that you should be creating objects for your data. You should not be just storing them as dictionaries. Dictionaries can work. Objects are the better way to go. We'll talk about this more with probably, we're going to review school interface 2 on Monday. We should. So we'll come back to the school interface problem if there's more questions, but hopefully that gave you kind of a nice introduction on how to start the school interface. Again, school is kind of like your manager. It keeps track of all the students and staff that we create. And then your staff and student classes obviously have some special data. So in this case, staff has employee ID. So that is an instance attribute on the staff level because employee ID does not make sense for a person because not every person has an employee ID, but every staff or student has some shared items like every staff or student has an age, has a name, has a password apparently, and a role according to your application. So that's why we kind of create this generic parent class or base class to kind of store the shared data. All right, so we're hitting